Okay, so today we're going to do the FEMAP for this video here. All right, so here we go. I'm going to create the points, and then I'm going to be careful also with the orientation of the surfaces, since we figured out it was giving some problems. So we'll be, all right, so it looks like I can do tools, no, geometry points. So which one I'm going to use? I'm not going to do it here on the Z. That would be fine. So it will be 0, 0. Looks like 500. Then 750. So I've done all the ones at the bottom here. We need to do the same thing here now at 250. So I'll go to Y 250. 750, 500, and 0. Oh, I forgot to put 1 or not. No, I think we're good. If we need to add points, we do it. Now we need to do the same thing at the tip, which is at 2000. Okay, so I'll go do the same thing. So we have 1 at 0, 0. X 250 and 750. Or was the other way around? It was, yeah, you see I put 1 here. I think the previous part I didn't put it right. Okay, maybe yes, 750 doesn't matter. So 750 preview. Well, it's going to the other direction. Okay. Yeah, I don't know what I've done here. That looks fine. Yeah, you see this one I put it on the wrong direction. I think I needed to put this one. So I think we can do delete, model, or geometry, point. I think it's that one. I think I needed to create the point here at instead of 250 was 500. Yeah. Now we need to do the same thing here at 250. So we need the 500. We need the 0. And we need the 750. All right, cancel. So that's the way it looks like. So, all right, so let's go. Geometry, surface, corners. So I'm going to try to create everything counterclockwise, so we don't get the problem here. So on point. So maybe let's start by the roots. So enter, enter, enter. Really, that surface is not needed, but okay, and then we need the top ones now. So here. Let's do the bottom ones. The sub one. And now the bottom one, so would be, oops, I need to be careful here. Let me do a cancel here. Geometry surface. So if it's at the bottom, we need to do reverse. All right, so method surface corners. Okay, so is that what we have here? Or maybe it's reverse, I'm not that sure. Now it's what we have, the 250, and then this one is a 500. So I think we should be okay. All right, so let's use the material properties. Let's use everything in millimeters. So 69,000 E and 25,900. All right, so model, materials, new. I don't know what the material is. So 69,000. Here put the 0.3, even though if you put the G, you should not need that value. But let's put it and 25/900. So it would be, I don't know what that material is, but let's say material, we don't need to put anything. And okay, cancel. So let's activate that material. Now properties, let me just use plates at the beginning so we can just check the deformation. So new, I'm going to plot here plates. I think the thickness was 2 millimeters for all of them, if I remember properly. Yeah, everything is 2 millimeters. Okay. Upper here too. Okay. Then what do we need to create? We need to create the ones for the rods. So new element property rod. What is the area that we have? So we have two different ones. So 650. So let's say B1, B3, B4, B6, or let's say 650. Might be easier. So B equals 650. For here 650. And the third one will be B equal 1300. And I put here 1300. Okay, cancel. So now Control A to recenter. So mesh control, size on surfaces, select all. So how much are the sizes here? It's like 250. Do we do a lot? Do we do every 50? I mean, let's do every 50 if we want to have a better result. That might be already a lot. I think that's already a lot, but it's fine. So now we can. What's the best way to first do the plates or first do the rods? Let's first do the rods. Let's do the plates, doesn't matter. So mesh geometry surfaces. I'm going to select all of them. Okay, with the plates. Okay. Now let me deactivate the plates elements, the property plates. And let's try to mesh this one. So we do now mesh geometry curve. So I'm going to select this one, this one, this one, and the bottom one. Then we're going to have to close those things. But for now, let's do this. So if I remember properly, those should be the 650. And let's mesh geometry curve. This one and this one should be the 1300s. Okay, so let's see. We created here the plate and the beam elements, but we need to close now these boxes here. So let's close everything using the 650s. Okay, so we're going to go to mesh geometry curve. So we need to close this curve, this one, this one, this one, this one, this one, I guess this one. Same thing at the back. Really at the back, you don't have to do it because it's going to be constrained, but it's not going to hurt to do it. And in order to do it, we're going to select the less stiff. So the 1300, let me select the 650 and okay. So this should be the, if I eliminate the surfaces. Okay, I'm not familiar with this menu on top. Oh, here we go. You see, this will be the wing box without the panels. Now we have the panels. We have this one. Okay. So we're going to add the constraints. So we do model, constrain. I'm going to do on surface. So let's say fix or clamp, cantilever, whatever you want to call it. I'm going to go to those two surfaces over here. I select fix. And now the force, we don't really know what it is. So if you want, we can create the spider web over here, or we can just apply it somewhere. So let's do first tools, check, coincident nodes, select all. Okay, preview should be all these nodes. The plate should connect to the rods. Done. Okay. All right, so now we don't really know where the force is applied. So whatever we can do. So which one you want to do? Do you just want to do like just put it here, or you just want to create the spider web? Let's create the spider web. I haven't done it for on a while, so remind me here. I think it's custom meshing. Wow, spider nodes, spider curves, spider nodes. Okay, I haven't done that in a while. So I guess I deactivated the geometry, so I'm gonna have to reactivate the geometry, I guess. Yeah. So methods on curves, I'm guessing. So select that one, that one, that one. And do I need to put a name to it? So ID. So add. Let me check here at the bottom what's going to be the number of the nodes. Okay. So let's see what I did here. 40 nodes selected. Okay. So all right. So so properties, elements. We can come here to elements by type. What I would do here, for example, is to eliminate the plates and these ones. So we only have this one here, the spider web. And here will come now model, load, nodal. So I don't know what it is. It's Vy equal to what was 44,500, I think. We're gonna get there, 44,500, yes. So, okay. So I don't know why I did this one, model, load, nodal. I think I did that already. So this one, okay, 44,500. All right, so here, you don't need to do this, but I don't know, I like to do it. File, rebuild, yes. We have the constraint, we have all the elements. Let's reactivate the roads and the bits elements. Generally, for you want to look pretty, you eliminate in this one. It doesn't look like. If you want, you can eliminate the nodes by clicking. I mean, I'm not familiar with this one, but you should have one with some type of little points. I think should be here. I think it's hidden by this. Yeah, I think this one eliminate the points. One of these one eliminate the nodes. Okay, I'm not sure which one. All right, doesn't matter. This one does for this. So now we go to here to analysis, manage, new, make sure it's static. Okay, analyze should go pretty quick. All right, so it's done. F5. I want to look at the contour, deform. Here, I'm going to show the total translation, but we want to look at only the Y deformation because that's the only one we calculated. Then we can look at the overall. And it's giving us, looks like 17.54 over here. It's not very clear, okay? So basically, it's giving us a little bit less than our approximate solution that we found to be 23.59. okay? So the error probably is because of the stiffness of the panels. I'm guessing here, so let's try something. All right, so let's say this is results. So this is the more realistic case, okay? This is the, if you want, it's more realistic than the one we did the calculations. So let's call this one here, let's say, let's call this one case 1 for T equals 2 millimeters. Because in our assumptions, when we did the calculation, what was the assumption? Is that the panels were not effective in resisting bending, correct? Okay, so basically we say the outer panels are not resisting any bending. So here you see, this was for 2 millimeters. So just now to see if it will change something, let's go here to this plate property, edit, and I'm going to move this to, let's say, whatever, 0.1 millimeters. So basically, I'm making them pretty thin compared to what they are now, no? Okay. And hopefully it's not going to give any problem. So I do this, file, rebuild. Yes, I reanalyze this. And maybe it's not going to give much of an error because everything should be resisted really by the elements, no? The plates are only there for the geometry, but I just wanted to check that stuff. So case 2. I cannot read. Well, we get a lot this time, no? How much do we get? I cannot read. Oh, 92.23. So completely unrealistic now, no? So that's not a good one. Then let's delete this one. I think it's just too thin, so it's deforming. Let me do something here. Yeah. Let me cancel this for a second. I want to look at something. Okay. I want to look at F5 here. If I look at the total deformation instead of just the F2. It stays, so it went a little bit up. Instead of 17.52, it went to 17.58. Okay. Again, let's rerun it now for 1 millimeter. I think probably that would be the good one. So 0.1 is just too thin. Johnny, use 1. File, rebuild. Yes. Analyze. And this should also help us to check for the shear flows. But so now this one will get 24. Wow, so it's making a difference that was not expected. All right, so let's keep it with 2. How's that? How can that be? All right, so let's do now another model to check something because I found this a little bit strange. So this is our save this one as file model. Plates. Okay. And let's modify this one to say I'm going to eliminate the analysis and the results. Just to make sure we don't have any problem. File, rebuild. And what I'm going to try to do now is change all the plate elements by shear elements. So what is property? Property new, element property. We go to shear panel. Okay, thickness 2. And okay. All right, so now how can we do this quick? I think it's modify, update elements. Yeah, update elements, property ID. So select elements, update property you want to do. So let's say method property. So we want to change the property 1. and it's not here. We want to use the 3. So why is or the 4? Why it's not here? Okay, do we need to select it here? So it's not giving us the choice here. No, that would be the same thing. Okay, so let me cancel. Control Z, cancel again. That's what we want to do. File, rebuild. I don't know why it's doing that, but it's modify update elements. Maybe it's type. Maybe I should have done that one. Type. All right, so let's say select elements to update is the so type would be 2. Method on property, maybe some property. So let's say would be property was 1. More, okay. Now it shows up when I need to create it. Okay, so all right. So again, shear panels. Okay, we put 2 over here. Oh, here we needed to put 0.0001, I think, and 0.0001 before I forget. Okay, so shear property. Okay. So let's see. So they should be replaced here. So now we're going to call this model here, file, save as, model, shear panels. Save, file, rebuild, yes, and analyze. Create, new, okay, analyze. Here we go, F5, contour, deform, deform. I don't want to see deform because I look horrible. Let's put it not deform. Ask more questions. So there's no data here. Let me see what happened here. Okay, so F5, contour, T2, okay, okay. So this time this is giving you, cannot read, 26.46. So none of the results are great. Here our approximation is 23.59. If we use shear elements, we get 26.46. If we use the plate elements, we got 17.52, no? If I remember properly. What's happening? Did I delete the data here or just been difficult? And we got here 17.58 using the plate elements. So as you can see, nothing is perfect, no? Okay. So I will stop the video here. If you want to go and check the shear values, you could go to this model shear and look at the values on the panels. Okay. If you look over here, when you put deform, you see what's happening, no? Is that some of these stuff are not staying attached. Okay. Only the panels. So that makes sense because when we say this one, conceptually, what do we say? Is that only the panels that in the direction of the force will be resisting the load, no? When we do the calculation. And that's exactly what you see over here, no? Only the panels in the direction of the load are displacing, deforming. The one at the top and the bottom, they're not doing anything. Okay? So you need to know the limitations when you also do the finite element modeling.